My name is Peter Cannell, and we're going to show you a little demonstration of sediment transport by rain impacted flow. On the left hand side we have a mixture of sand and soil, while on the right hand side we have soil in the top section and the medium sand on the rest of the bed. Water flows from the back to the front at constant depth and velocity over the whole area, and we apply rain using 2.7mm drops at 100mm per hour intensity. Initially we get a flush of fine sediment, which in this case will disappear fairly quickly. And then we get the development of, on the right hand side, of a wave of sediment moving across the surface by raindrop induced saltation. Now this wave takes a while to develop and move across the surface, so we're going to speed this process up just shortly. Here we go. Now going at 5 times normal speed, and as you can see, the wave of soil material is gradually moving across the surface. Going back now to normal speed as we're getting towards the end of the demonstration in this particular little segment, and what we end up in is a surface looking like this, where you see there's some material moved away from the original point marked. In this second little demonstration we're going to show you something that starts off with the same basic consideration but ends up with a different pattern of movement in the end. Basically we still start off with a flush of fine material, and then that leads to material just moving by raindrop induced saltation, but also you can see material moving quite fast across the surface by raindrop induced rolling, and these particles are actually moving much faster than by raindrop induced saltation. Obviously this thing takes, like before, time for the patterns to develop, so we're going to speed things up. Here we go at 5 times speed. And as you can see, sometimes the particles move as individuals, but then at times they tend to clump together. This is particularly being seen on the left hand side. Something we really didn't mention about on the left hand side is that basically you're winnowing the soil material out of the sand, so that you're cleaning the sand, except for those particles that are obviously sitting on the top and getting clumped together, and these things take time to move across the surface. So we're getting on the right hand side an appearance of something like dune movement. As you can see, the particles are taking time to move across the surface. And now we're coming towards the end, so we're going back towards normal speed. We've been running the experiment now for just on 10 minutes. Now we show you a little morphing scheme where we start off with the original surface and morph through to the end. And basically we've shown you three different transport mechanisms: flow driven suspension, and then you've got raindrop driven saltation and raindrop driven rolling. In this situation we have biochar mixed with sand on the left hand side and at the back on the right hand side. The biochar has particles of various sizes, and initially we get a flush of the fine material that's moving out by complete suspension and raindrop induced saltation, and also we're getting particles that are moving by raindrop induced rolling. Some of the particles moving by raindrop induced rolling move quite quickly, but the bigger ones tend to be angular and tend not to move so freely. On the left hand side you can see the surface whitening as the biochar is winnowed out, and the same applies to the top on the right hand side, so the actual amount of biochar that's coming out of the top is being reduced on the right hand side and on the left hand side, so gradually as time goes by much of what is moving and being discharged is just sand, which you actually can't see moving. We're running 8 times speed because again this takes about 10 minutes to run through to the end. As you can see, the particles are moving quite quickly, apparently in the rolling, but actually at normal speeds that's not quite so. Here we are back at normal speed, and as you can see the particles don't move quite as fast as you perhaps appeared earlier by the rolling mechanisms. Okay, now we've stopped the experiment and you can see the difference of the surface from what it was in the beginning. Some coarse material left on the top. This is a morphing through time-lapse to initially see the initial flush and the gradual removal of the biochar from the surface on the left hand side. Basically throughout the experiment sand is still moving basically from the back to the front, and so there's still sand moving even though the biochar is moving, and the sand moving causes a layer of sand to develop across the top of the biochar layer that's been winnowed out, so it protects the underlying surface from being eroded and the biochar removed.